Betelgeuse is a massive star, roughly 10 to 20 times the Sun's mass and over 1 billion kilometers wide. It's in its late life stage, burning heavy elements like helium and carbon in its core, which makes it unstable. This instability causes it to pulsate, expanding and contracting over cycles of about 420 days, plus a longer 6-year rhythm. These pulsations are like a star's heartbeat, driven by convection, giant, bubbling cells of hot gas rising and falling, some as big as Earth's orbit around the Sun. Recent observations, especially since the Great Dimming of 2019 to 2020, show this convection getting extra rowdy. In that event, Betelgeuse faded dramatically, dropping to 40% of its usual brightness, due to a massive ejection of material that formed a dust cloud, blocking its light. Studies from 2024, like one from the Max Planck Institute, suggest its surface is boiling more violently than expected. Telescopes like ALMA have caught these convective bubbles in action, with gas moving at speeds up to 30 km per second, creating a wobbly, uneven surface. Some even thought it was spinning fast, 5 km per second, but that's likely an illusion from this turbulent churning, not true rotation. Vibrating violently, what does that mean? The vibrating bit likely ties to these pulsations and convection ramping up. In early 2024, research in the astrophysical journal Letters proposed that Betelgeuse's surface motion mimics rapid rotation, with hot spots and cool patches shifting chaotically. Add in a possible companion star, Betelbuddy, stirring the pot by plowing through surrounding dust every 6 years, and you've got a star that looks like it's shaking things up. Posts on X from late February 2025 amplify this, with some claiming it's flickering or vibrating more than usual, based on amateur observations and hyped-up YouTube videos. But violent? That's relative. For a star this size, convection is naturally intense. Think of it like a pot of water on a cosmic stove, simmering hard as it nears the end of its fuel. It's not a new vibe, it's just Betelgeuse being its chaotic self, now better seen with cutting-edge tech. Is the end near? Here's the big question, does this mean Betelgeuse is about to blow? Short answer, maybe, but probably not soon. It's destined for a Type II supernova. Its core will collapse into a neutron star or black hole, blasting its outer layers into space with the force of billions of suns. When? Estimates range from tomorrow to 100,000 years from now. The catch, we can't predict it precisely. Stars like Betelgeuse don't send RSVP cards for their finales. The Great Dimming sparked supernova buzz, but it was just a dust tantrum, not a death rattle. NASA's Hubble data from 2022 showed it was a plasma outburst, not core collapse. The 2024 boiling surface findings and brightness swings, it's been erratic since, hitting peaks in 2023 and dipping again by March 2025 per AAVSO reports, keep the speculation alive. Kaku might call it nature rewriting the script, but he's not betting on an explosion this decade, more like a chance to study a star in its twilight. Why the hype? Betelgeuse is close, about 640 light-years away, and bright, so a supernova would be a daytime visible spectacle, outshining the full moon for weeks. That's catnip for attention-grabbing headlines. X posts from February 25 to 28, 2025, scream live supernova now, but they're likely riffing off old data or misreading variability. No credible science as of March 1, 2025, says it's popping off tonight. 1. Betelgeuse Basics. Betelgeuse is a red supergiant, a bloated, dying star in the Orion constellation, about 640 light-years away. It's massive, 10 to 20 times the Sun's mass, and huge. If it swapped places with the Sun, it'd swallow Mars' orbit. It's old, maybe 8 to 10 million years, and in its final act, fusing heavy elements in its core. When that fuel runs out, silicon to iron is the last step, it'll collapse and explode as a supernova. That's its destiny, but the timing? A cosmic shrug. 2. What's vibrating violently mean? The vibrating comes from Betelgeuse's natural pulsations and surface turmoil. Pulsations, it expands and contracts over 2 main cycles, 420 days and 6 years, due to instability in its outer layers. Think of it like a balloon inflating and deflating as internal pressure swings. This shifts its brightness, magnitude 0.0 to 1.6. Convection, its surface is a roiling mess of giant gas bubbles, convection cells, some 100 million kilometers wide, rising and sinking. Recent studies, e.g., 2024 Max Planck research via ALMA, clock these at 20 to 30 km/s, fast for a star. Hot spots glow brighter, cool patches dim. Recent drama, since the 2019 to 2020 Great Dimming, when it faded to 40% brightness, Betelgeuse has been erratic. That event was a dust cloud from a gas outburst, not a supernova sign. By 2024, high-res imaging showed its surface boiling more intensely, big, uneven motions mimicking rapid spin, debunked as 5 km/s rotation. It's just convection chaos. The violent tag? It's exaggerated. This is normal for a red supergiant, just amplified by Betelgeuse's size and our better telescopes. X posts in late February 2025 hyped flickering or shaking, likely from brightness dips or misinterpreted data, but it's not a new behavior, just newly spotlighted. 3. Why it's stirring up talk. Betelgeuse has been a supernova tease for years because brightness swings. Post-dimming, it hit a peak in 2023, brighter than usual, then dipped again by early 2025. AAVSO logs show it hovering around 0.5 to 1.0 magnitude. This roller coaster fuels speculation. Surface weirdness. A 2024 Astrophysical Journal Letters study suggested a companion star, Betelbuddy, might orbit every 2,100 days, 6 years, stirring dust and adding to the chaos. That's unconfirmed but adds intrigue. Public imagination, a supernova would be epic, visible by day, outshining Venus for months, safe at 640 light-years, but dazzling. Headlines love that hook. 4. Is the end near? Here's the supernova scoop. Life stage, Betelgeuse is likely fusing carbon or oxygen now, with silicon and iron next. Iron fusion takes days. Once that starts, collapse is imminent. But we can't see inside its core to know where it's at. Timing, estimates range from any moment to 100,000 years. Statistically, it's near the end. Red supergiants live fast, die young, but near in stellar terms could be centuries. The Great Dimming was a false alarm. Hubble confirmed a plasma ejection, not core collapse. Signs, violent pulsations and outbursts are par for the course, not a death knell. A real precursor might be a sudden neutrino spike, detectable only days before, but we're not there. As of March 2025, no data screams imminent boom. The Vibrating is just Betelgeuse doing its late-life dance, louder lately, but not terminal yet. 5. The science angle. Astronomers are loving this, not panicking. Better tools, JWST, ALMA, and VLT, Very Large Telescope, reveal Betelgeuse's surface like never before. Think of it as a stellar ultrasound. The 2024 findings show convection dominating, not rotation, refining models of dying stars. Mass loss, it's shedding 1 to 2 Earth masses of gas yearly via winds and outbursts, building a dusty shroud. That's typical prep for a supernova, but over millennia. No alarm, experts like Emily Levesque, 2023 interviews, say it's acting up, not blowing up. Kaku might call it a cosmic signal, but he's not betting on 2025 fireworks. Betelgeuse's so-called vibrations aren't a single tremor but a mix of wild behaviors. Pulsations, it's a semi-regular variable star with 2 dominant periods. For 20 days, the primary mode its radius swings from 700 to 900 times the sun's size, shifting brightness by a magnitude or so. This is tied to internal pressure waves, sound waves bouncing around its core, amplified by its bloated, low-density envelope. 6 years, long secondary mode a subtler cycle, possibly linked to deeper convection or a companion star's influence. Recent data, 2024, monthly notices of the Royal Astronomical Society, hints this might have sped up post-2019. Convection chaos, picture a star-sized lava lamp. Huge cells of plasma, some 100 to 200 million kilometers across, bubble up at 20 to 30 km/s, cool, and sink. Almost 2024 imaging shows these as blotchy hot spots, up to 15,000 K, and cooler dips, down to 3,000 K, making Betelgeuse look like it's wriggling. This isn't new, it's just more vivid now with better resolution. Outbursts. The Great Dimming, 2019 to 2020, wasn't a one-off. Hubble's 2022 follow-up pegged it as a surface mass ejection, a chunk of outer layers blasted off, cooling into dust. Smaller ejections keep happening, with SOFIA, Infrared Observatory, noting gas plumes in 2023. This ties to convection spikes, where bubbles burst out, not just rise. The violent label comes from this combo, pulsing, boiling, and spitting gas, looking frenetic on a human scale. But for a red supergiant? It's par for the course, just louder lately. 2. What's driving the show? Betelgeuse is in its death throes, and that's messy. Core evolution, it's likely past helium fusion, which lasts 1 million years, and into carbon or oxygen burning, hundreds to thousands of years each. Each stage ramps up instability, faster fusion, more neutrinos escaping, less grip on its outer layers. Silicon fusion, days, and iron, hours, are next, but we can't tell from outside. Low density, its outer edge is so diffuse, 10 to the power of -13 times Earth's air density, that it barely holds together. Gravity's weak out there, so convection and pulsations rule, tossing material around. Beetlebuddy hypothesis, a 2024 study from UCL suggests a companion star, maybe 1 to 2 solar masses, orbits every 100 days, plowing through Betelgeuse's windy ejecta. This could tweak the 6-year pulse and stir dust, though it's unconfirmed. JWST's still hunting for proof. Since the Great Dimming, its rhythm's been off. Brightness logs, AAVSO, March 2025, show it peaking at 0.2 in mid-2023, dipping to 1.0 by late 2024, and wobbling now, less predictable than pre-2019. That's got folks watching. 3. Supernova countdown, where are we? Betelgeuse will go supernova, its mass guarantees it, but when? Core clues, iron fusion is the endgame. Once that starts, the core collapses in seconds, triggering the blast. We'd see neutrinos first, detectors like Super Cameo Candy would catch them days ahead, then light. No neutrino spike as of March 2025. Timescale, estimates are fuzzy. Optimists, 10 to 100 years, if it's on silicon now. Pessimists, 10,000 to 100,000 years, if carbon's still cooking. Reality, no one knows. Red supergiant lifetimes vary, and Betelgeuse's mass loss, 1 to 2 Earth masses/year, suggests it's shedding fast, but that could last centuries. Pre-signs, violent pulsations and outbursts aren't reliable harbingers. A sudden, extreme brightening, days before, or spectral shift, iron lines spiking, might hint, but we're not there. The 2024 boiling is cool data, not a death knell. X posts from February 2025 screaming it's now lean on old flares or brightness dips, e.g., a 0.8 magnitude drop in January 2025. No science backs an imminent bang. 4. What if it blows? If Betelgeuse pops. Brightness, at 640 light-years, it'd hit -10 to -12 magnitude, brighter than a full moon, -12.7, visible day and night for weeks, fading over months. Safe, no gamma rays would fry us. Sky show, a pinprick turning into a blazing star, then a nebula, like the Crab Nebula, over decades. Orion's shoulder would vanish, redrawn by debris. Science bonanza, neutrinos, gravitational waves, and light would flood detectors, our first close-up of a core collapse supernova since 1987, SN 1987A, 168,000 light-years away. Kaku'd geek out, calling it the universe's grand finale on live TV. But it's not queued up yet. 5. Why it's hot now. Tech, JWST's infrared, ALMA's radio waves, and VLT's optics map Betelgeuse like a 3D model. 2024 images show it wobbling like jelly. That feeds the violent vibe. Post-dimming hype, the 2019 fade flipped the script from stable giant to unpredictable diva. Every twitch since, like a 2023 peak or 2025 flicker, gets amplified on X or YouTube. Cultural pull, a supernova this close? It's sci-fi made real. Headlines thrive on that. 6. The verdict. Betelgeuse is vibrating, pulsing, bubbling, ejecting gas, with more gusto than expected, thanks to its dying star physics and our sharp-eyed scopes. Violently as flare, it's a natural tantrum, not a breakdown. The end? Near in cosmic terms, a blink of 10,000 years, but not tomorrow. It's a slow-motion car crash we're privileged to watch, frame by frame. No panic, just awe.